review for Unit 8. Unit 8 is where we talked about two variable data. Number one, the table shows the data of a group of men and women that were asked what their favorite sport was, given just the categories provided. What is the relative frequency for this group that either male or female would choose basketball? So the relative frequency is a percentage. We're finding the percent of men and women that would choose basketball out of this table. So if you look, we've got the men and women right here, but we already have the total here. So we're going to use the total men and women, which is 70, and we want a percent. So we're going to do part out of total and then times it by 100. In this case, it's 70 is the people that like basketball out of the total number of people asked, which was 232 people. And then we're going to multiply that number by 100, which gets us about 30. So it would be about 30 for the relative frequency, because that is the percent of people that were male or female that would choose basketball. Number two, Rip Van Winkle has fallen asleep for a long time. The graph below describes the length of his beard in millimeters as a function of time in weeks. How long will his beard be after 1 year if this pattern continues? So what we have, we have the line, and we see it is linear. So if we're able to come up with an equation for the line, then we can figure out how long his beard will be in a year. So 1 year, notice that we're in weeks here for the time. So 1 year is 52 weeks. That's something that we need to know. And then we are going to need to find the equation of this line. So we know that it goes right through 10. And then the next place where the graph crosses exactly through the grid would be at 10, 35, right here, 35. And then if we keep going, the graph should cross again at 20 and 60. And then again, one more time if you wanted to mark all these points where it's crossing right through, and that would be there. So if we find the rise and run here, notice that the graph doesn't go by 1, so we can't just go up 1, 2, 3, 4, 5 squares. We have to count it by 5s because that's what the graph is doing. So here it's 5, 10, 15, 20, 25, and over, let's see, the graph goes over to 10, right? So here's 0 and it goes over to 10, because the bottom of the graph is going by 2.5 every time. So this is 7.5. So you're going 1, 2, 3, 4, and that shows 10 right there. It's over 10. So 25 over 10, and again, that's going to continue our pattern, 25 over 10. 25 over 10 is our rise and run, which is our slope, that rate of change. And if we reduce that, 5 goes into 25 5 times, 5 goes into 10 2 times. So our reduced slope would be 5 halves. So we would have y equals 5 halves x. And we do know that the y-intercept goes through at This is our y-axis, goes through at 10, so it'd be plus 10. So this is the equation of the line. So now we're able to plug in any amount of weeks and know how long his beard is going to be. So in this case, if it's 52, we're going to plug in 52. Y equals 5/2 times 52 plus 10. So that'll give us, after 1 year, how long the beard will be. And if you plug that in there, you get 140 millimeters, because everything over here is in millimeters. So that is the length of his beard after 1 year. Okay, number 3, draw the line of best fit and write the equation for the best fit line. So one thing that's really helpful to do, if I want the line of best fit, and notice it does, these dots do look like it's going to be a linear line of best fit, not exponential or anything else. It does look pretty much like it's in a line. So what I would do, especially if I want to use the calculator to help me get the exact line of best fit, I'm going to write out the ordered pairs for every single one of these points. So I'm going to start with 58 and 100. And the next point we got 60 and 120 for this one. And I'm just going to keep going and write out the other points that are listed. So 62, 130, 61, 135, 62, and 145, 63, 135, 64, 140, and 66, 145. So this is when I would go into my calculator and go into stat, enter, and I would type in all those numbers into list 1 and list 2 because I have the x values and the y values. And then after that's done, you go back into stat, over to calc, and go down to number 4 for this one because that's where it's going to have linear regression. And in this case, it comes out with y equals 5.23x minus, so the y-intercept would be 193.5. And if I want to graph this, I want to draw that line of best fit into this graph. The easiest way to do that would be to get 2 points that are on this best fit line. So I just picked 2 different numbers that I could plug in to the equation for x. So I chose, I'm going to put it over here. I chose the number 58 and I plugged that in to the x, and so 5.23 times 58 minus the 193.5, and you get 109.84. So that's one of the points I can graph. So 58 would be 58 there. And then it's real close to that point. So we got, it's a little bit higher though. We got 109. So it's almost 110 there. And then I plugged in 65, just 2 different numbers that are on this for the x values, and the output was 146.45. And so if you go to 65 and you go up to 146, we're about right there. And then all you got to do now is just connect the points and make that line. So it would be nice, exact, linear line there. The line of best fit for those points would look like that. And that would be the most exact we could get. Use this given plot to create a residual plot. The residual plot, again, remember, is how far away the numbers are, or sorry, the points are from the line of best fit. So for this one, and it's the vertical change from the line of best fit. So vertically, this point to begin, it looks like it's about 5 above the line of best fit vertically. So what we're going to do over here is this would be our 0, and then we are just going to go by ones and mark all of the different values. How far away are our points from the line of best fit vertically? So the first one, we know it's at the number 10 here. So we're going to go to 10 and we're going to go up 5 because it was 5 higher or 5 more than the best fit line. So we're comparing how far away are our points from that best fit line. And so if we go to 11, this one, it looks like it's like 94 here and maybe up here 99. So I would say that's about 5. Again, we're kind of got to estimate that. But this would be 5 down then. 1, 2, 3, 4, 5. Because it was 5 below for the best fit line. So the next point we have is this one, which is not very much away. It looks like it's probably just 1 away because we're going here about probably 104 to 105 for that one. So go to 12 and then we go up 1 because that was a vertical up change from our line. So vertically, to get to the line, how much change occurs? This one looks like we're pretty much halfway, maybe in between 105 and 110. I would say that's 107.5. But you could estimate something a little different depending on how you see it. And up here we got 115. So I would say that's a vertical up of from 107.5 to 115. I would say that's about 7.5. So I'm going to go to 13. I'm going to go up to 7 and then in between 7 and 8. That's our vertical change from our best fit line. The next point looks like it's going down, and it looks like it's 1 below on that one. So 1 below our best fit line. The next one is also below, and it's at least 5 away because that's 1 full square and then a little bit more. So we could say 6 or not quite 6. It's up, see how you see it. So we're at 15. We're going to go down at least 5. 1, 2, 3, 4, 5. I'm going to just go to the 6 and show that it's that vertical change. And then the last point here, it looks like it's right on the best fit line. So there is no vertical change, so we are just going to put a point right on the 0 line. So looking at this helps us see how well the best fit line fits our data. Notice that the points are higher and lower, and it's a good mix of both. So that's what the best fit line should look like in a residual plot, being scattered up and down. Correlation with or without cause, number 5. The number of storks, stork is a bird, and the birth rate in Denmark. So the number of